and the molecular weight. And most of the times we'll give you the molecular weight. You may calculate the I factor, or we'll even give you the I factor. All you need to do is substitute in the given formula. So we have now the I factor. We have its molecular weight. We know the molecular weight of sodium chloride, and we know its I factor. So how do we calculate the sodium chloride E value for papaverine? We just substitute in this formula. Molecular weight of sodium chloride is 58.5. Its I factor is 1.8. Multiplied by the I factor of papaverine, 1.8, divided by the molecular weight of papaverine. When you do that, multiply those which are on top, 58.5 by 1.8 equal to, divide by 1.8 by 376, you get the answer. So it means the value of papaverine is 0.156. So this value is important, more especially when you are told to prepare an isotonic solution and you have not been given the sodium chloride E value for a substance. Remember, we require the E value in step 1 as we calculate the required quantity of sodium chloride in that preparation. So in step 1, this is very, very much useful. And in step 4, if it's a non-electrolyte. Unless there are questions, are we on the same page, page 1?
Yes, sir, we are on the same page.
Thanks, Kennedy. Are we on the same page, the others?
Yes, sir, we am.
Yes, sir.
Yes, sir.
Good.
Yes, sir.
Okay. All right. Wonderful. Let's move on to example number 2. So example number 2, we are basically using the same formula. You're using the same formula, same principles, but we are going to give an example on a non-electrolyte, so that whichever question you are asked, whether on a non-electrolyte or an electrolyte, you are going to know how to calculate. So let's look at this example. Calculate the sodium chloride equivalent of glycerin. In brackets, there is a molecular weight of 92. A non-electrolyte. Sometimes will not guide you that this is an electrolyte, this is a non-electrolyte. No, will not guide you. You have to know that certain substances like boric acid, dextrose, glycerin, you have to know that these are naturally non-electrolytes. Okay, so take note here that I factor for a non-electrolyte is 1. I think we agreed on this when we were doing I factors. So I factor for any non-electrolyte, be it dextrose, urea, the same glycerin, boric acid, I factor will always be 1. So when you have a question and it's guiding you to say this is a non-electrolyte, just know the I factor there is 1. Okay? Like I said, always know the molecular weight and I factor of sodium chloride. They are good. The only thing you remain with is this is electrolyte. We have been given in the question. So the only thing we do now here, we have all the things we require. We just substitute, multiply, divide, and get our answer. Just do that and confirm that you have got the same answer as this one written here, 0.350. Are we okay?
Sir, I have a question.
Yes, Chris.
Yeah, I think I didn't get you in the first question. You started about 1.8 for sodium, well, like the I factor. Is it a standard D or what?
Okay, okay, an answer for me that question.
Yes, it's the
Yeah.
standard.
Yeah, because it was cutting in the first place, so I didn't get what you said when you started the lecture.
Okay.
Yeah.
I
Yes.
also think. Can I try, sir? Yeah. So the I factor for sodium is depending on the dissociating ions in the molecule. So sodium has got sodium and the chloride. It's a sodium chloride. So the ions that are dissociating are two of them. So when we are doing the dissociation factor calculations, that's how we are coming to get the value 1.8.
Yeah, so it's simply also telling us that even sodium chloride, the one we did. So it's 80%.
Yeah, I think that's where I was lost because.
So
Okay,
sodium.
that's where I was.
Okay, Chris. So meaning for sodium chloride, like I was saying, you have to know it, know the molecular weight and its standard dissociation factor, 1.8. So it will never change to 1.6, 1.5 or anything. It will always be 1.8. And the molecular weight was 58.5. Okay, Mr. Cluster.
Okay, thanks.
Good. Any question, any addition? We move on.
I've got a question, sir.
Yes, Peter.
Yes, sir. Thank you. On the answer for the E value of glycerin, mine is giving me 0.353. So on the answer here, I can see 50. So I wanted to ask as to why there's a 0 there instead of a 3.
Okay, well, if they do the calculation and confirm that is giving you is 0.350. Who found a different answer?
Just like Peter's answer.
That's Davidson.
Yes, sir. I got this 0.353.
53.
Yes.
Who else?
I equally got
0.3. Okay. That is correct. but a 3, right? Are we okay? 0.353.
Yes, sir.
Okay,
Yes, sir.
good. All right. Thanks, Peter. At least you've saved many souls since you are in event. Yeah,
Alright.
Yes,
yeah,
sir.
in event today. Thanks.
You're welcome, sir.
We move on to example number 3. The reason for example number 3 is that sometimes certain questions may use what we call incompatible substances. You know what it means when something is not incompatible? If you're trying to dissolve maybe sodium chloride in silver nitrate, you find that sodium chloride does not actually dissolve in silver nitrate. So if it cannot dissolve in silver nitrate, then you need to find a suitable substance to use. Definitely, when making calculations, you use what you are given. But at the end, you need to change things so that you use an actual substance in which sodium chloride can dissolve. When you mix those two substances, whichever dissolves in the other must dissolve. But when they are incompatible, they will not actually dissolve. They may just form what we call crystals. And imagine this is maybe an eye preparation or eardrops. Then it forms crystals. It means it will not be useful. It will not be used. No one will use that thing. If it's a substance or a product that is already on the market, if the regulatory authorities are actually going to recall that substance or product. You know what recalling means? To recall, it means removing from the market or from the supply chain a substance that is already being used. So we are saying the regulatory authority, I'm sure, will be informed by other people, maybe the pharmacovigilance unit and so on, to say this product is crystallizing. It has to be used for eye problems, but it forms crystals, so we can't use it because what they used when preparing that were incompatible ingredients or excipients and so on. So it is important that when a substance is being prepared, everything must be compatible. We don't want a substance whereby after maybe 2-3 months on the market or 6 months, even a year, it starts forming crystals. But manufacturers go on to do so. They know, but they go on. The reason they do so, they know that, oh, this substance is going to start forming crystals after a year. I'm sure by then we would have finished supplying. Why are we doing so? Because this other substance or solvent we are using is the cheapest. Maybe this solvent costs $10, and that's the cheapest. The rest of them, they cost $1 million. So manufacturers will still go on and form and manufacture certain drugs using such substances, but later on they are going to start crystallizing. So that's the reason for example number 3. So even if you know that what we require is this, you use it for calculations, but when preparing, you use the best choice ingredient or the suitable ingredient or excipient. So we look at silver nitrate being used to prepare an isotonic solution. So the question is, how many grams of potassium nitrate could be used to make the following prescription isotonic. So you can see from the question, it's saying how many grams of potassium nitrate. But when you look at the formula, you have been given silver nitrate. Okay? Yes, we are going to use silver nitrate, but it's not compatible with sodium chloride in making a solution that potassium nitrate is the best choice for this preparation, and it will not be incompatible with the sodium chloride. Where is my... I don't know what's happened to the screen. Okay. So, given solution of silver nitrate, 60 mils, 1 to 500 weight in volume. So there are some things you need to take note. 1 to 500 weight in volume. We already did this in class. Then you make a isotonic solution as eye drops for the eyes. Take note, the sodium chloride E value for silver nitrate is 0.33. When you see the E value, just know that there's things to do with step 1, step 2, step 3, and so on. Then you go back. What are we preparing? We're preparing 60 mils of this 1 to 500 weight in volume solution. I don't know what's happening now. How possible is that? How possible? Meeting says it's ending. Okay, here is the solution. 1 to 500 weight in volume means in 1 gram in 500 mils. Therefore, how many grams will be found in the 60 mils that we are preparing? X in 60 mils. So in the 60 mils, you are going to have 0.12 grams of silver nitrate. Okay, 0.12 grams of silver nitrate. So if you look at this, the 0.12, it's the same as getting this 0.12, get the 0.12, it's the same as removing this, right? Removing this and just saying you remove this, three, divide by sodium chloride E value for that substance. Okay, so we are using potassium nitrate. So potassium nitrate has a sodium chloride E value of 0.58. So whatever we found in step 3, just divide by 0.58. This part is the same as what we did in step 4 last week. The only difference is that when the substance is incompatible, that is in the formula, and you're using the one in the question. When you reach step 4, divide the E value for the substance in the question by what you found, by the grams you found in step 3. Well and good. Unless there's a question for what's this? For
Yes, I do have a question.
step 1. Yes, go on.
how are we going to be able to know that the compounds are equation, or we just have to know?
Yes, yes. If it's a question, I would definitely have to guide you. Okay. Hello?
Okay.
Yes.
Hello, sir. Yes.
For class purposes, I would definitely guide you that the question in the substance in the formula is incompatible with the sodium chloride and so on. But for manufacturers and those who are going to join the manufacturing industry, is that they have a list of these substances, and they know that, oh, this substance is incompatible with this one is incompatible with this, but we can use its formula to generate what we need.
So I have a
Okay.
question.
Yes.
So you said the manufacturers they use these incompatible elements to form the solution. So when they use it, is it going to give them an isotonic solution?
No, I didn't say
Oh.
they use. I didn't say they use these substances which are incompatible. Who got me correctly?
Hello, sir.
Who got my explanation? Yes.
I got it. You said that I'm speaking, sir.
Yes, I'm getting you, Derek.
Yes, you said that the manufacturers are who actually list the compound which are incompatible, so that we know that okay, they have got a list. They have got a list of compounds which are incompatible, so they are already there. So they will let us know that this compound and this are compatible. This compound and this are compatible. They are listed already, but that does not mean that they use incompatible compound to make a solution, a solution. No, but they are there.
Thank you.
Yes, sir.
So you find that you have a formula to use, but that formula you have, the substance which is there and maybe your solvent, you find that they are incompatible. So you're just going to use that substance as a stepping stone to get to where you want to. To get to where you want to go, you want to prepare a potassium nitrate solution or potassium nitrate combined with sodium chloride and so on. But the only formula you have at hand is that of silver nitrate. You use silver nitrate for a calculation, not for preparation of the actual substance. Not for preparation, but for, please, Chris.
Yes, sir.
The meeting is about to cut. So I've sent you another link because there's one more example remaining.
Okay, sir.
All right. So I'm saying you are using that silver nitrate not to prepare an isotonic solution, but to use it just for calculation purposes. Like we are doing, as we are calculating and we know now what is required. So what is required is this amount of potassium nitrate. That's the one we are going to use. We won't use the incompatible substance, the silver nitrate. Are we together? I didn't even get the name. It's good when you ask a question, you are saying something, because some people's names are not saved.
It's Kennedy, sir. Thank you very much. I'm
Oh, Kennedy, yeah, I can see. Kennedy, all right. Okay, so we proceed. Another question. Someone with a question as well on this. So we proceed to example number 4. That is our last example. Davison.
Sir?
Who's that one? Your son?
Which one? No, my cousin.
Don't lie to us. It's a female. I'll tell Peter to charge you, Davison.
No.
So we look at the last example, example number 4. The last example is a very simple one. It's simple, very simple than all the other examples we've been doing. The only thing is that I give a scenario. You are given I give a scenario. You are given a new substance or a new product on the market. That is in the question called that new product is being referred to as maybe ingredient X in the question or in the formula that we have. So you have a new ingredient in a preparation, but this new ingredient or compound or substance, maybe you'll be given the molecular weight, because people, as the scientists are there, as they are preparing, they will know how many carbon atoms are there, how many hydrogen ions, how many oxygen ions, and so on. So they will give you the molecular weight of that substance or compound, but they don't know its E value. They don't know its E value, okay? They'll try to put it in a solution to have it so that it dissociates. They'll even tell you to say, okay, it dissociates maybe 60% or 40%. Therefore, they will know that, okay, there are 4 ions or 3 ions and so on. They can even calculate the I factor for you, but they don't know its E value. You as a pharmacist must be able to now calculate for the E value of that substance. So you'll be given, they'll say, okay, it's got this I factor, it's got this molecular weight. As we don't know these things to do with E values, so you are supposed to be the one to help us calculate this for this. And that's why, even as calculations may seem to be simple, sometimes complicated and so on, they are very useful. And that's why in industrial pharmacy, those that feel they'll do such things, you again find such calculations. Simple as they may seem, but they are very, very important. Imagine you make a simple mistake in a calculation and you're preparing batches and batches of drugs. What will happen? You have to recall all the batches after some time if you realize that there was a mistake. I don't know if that company can pay you or if they can hire someone and fire you. So these calculations are very, very helpful. In clinical pharmacy, that's hospital-based practice, or in industrial pharmacy, more especially in industrial pharmacy, because in the hospital, these will come as already prepared products. Okay, so how many grams of sodium chloride should be used in compounding the following prescription? So in this formula, we have ingredient X, 0.5 grams. Sodium chloride, add to specific volume or quantity, then purified water, add 50 mils. So we are preparing that and make this solution isotonic. It's for use in the eyes. So these are eye drops. Let's move on. Compound X has an I factor of 2.4 and a molecular weight of 295. So in short, they're telling us that we don't know the E value for this compound. We have given the I factor and we have given the molecular weight. So can you prepare for us the E value? Or can you find the E value for us? You find the E value for them, then say, okay, we are preparing now this isotonic solution. So the only thing here in this question that is missing, that we didn't need, is the E value. And today we have done a calculation on how to prepare, how to find the E value. Once we find the E value, then we can use it to start step 1, proceed to step 2, and then step 3. Okay, we move on. Let's calculate the E value for this compound X. E value, we say it is equal to molecular weight of sodium chloride divided by I factor of sodium chloride multiplied by I factor of compound X divided by molecular weight of compound X. If you look at the formula which is here, I haven't put molecular weight, I factor, and whatever. I've just gone straight forward. 58.5 is the molecular weight of sodium chloride, I factor 1.8, multiplied by the given I factor divided by the given molecular weight, and we get something like 0.26. So please confirm with me that this E value is actually 0.26.
It is, sir.
Good. Now we need to find, in step 1, the amount of sodium chloride represented by this 0.5 grams of compound X. Remember what we do. We just get the sodium chloride E value for this compound and multiply by the given quantity there, the mass. Then that means you have found the mass or the quantity of sodium chloride represented by that compound. So in this case, we multiply what we have calculated, the E value, and the quantity which is in the formula. It's 0.130 grams. Then step 2, 0.9% means 0.9 grams in 100 ml. X in 50 mils. So it simply means it's the same when you do your proportions, it's the same as 50 mils multiplied by 0.009. Why is this 00? Remember, 0.9 in 100 mils. So it's the same as 0.009. So multiply by 50, you get 0.450. I don't want anyone to get lost here. 0.009, that is our 0.9%. Do 0.9% gives 100 mils. X gives 50 mils. Find the answer there to give you 0.450 grams. Step 3, the simplest, like we said last time. Step 3 is equal to step 2 minus step 1. 0.450 minus 0.130 grams is equal to 0.320 grams. Okay. Unless there is a question, I think this part must be easier.